Welcome to a totally radical edition of Comet Algebra. This video is for Algebra 1, Chapter 11, Section 8, titled Radical Equations. Now, by definition, a radical equation is an equation that contains a variable under a radical sign. So let me show you an example of something that is not a radical equation, just for clarity. If you had x minus square root 2 equals, say, 5 square root 2, this isn't a radical equation because this x isn't under a radical sign. This is just a straight up one-step equation where you'd add a square root 2 to both sides and you get x is 6 square root 2. Okay, not a radical equation. Here, like looking at example 1 here, this is a radical equation because the x is underneath a radical sign. And this requires some skills for us to learn. So solving radical expressions, again, you can tell this is important by all the fabulous stars here. You need to isolate the radical on one side of the equation. Isolate means get the radical all by itself if it's not. And when it's all by itself, then you can do the inverse operation, which is squaring both sides of the equation. After you square both sides, then we have to finish solving. And this one is very important to check your answers. In radical equations, sometimes our algebra is perfect and we do all the work perfectly. We get an answer, but when we put it back in, it's a garbage answer and it doesn't work. And that's because of the negatives involved. We have to be careful when we're taking the square root of something. You can't get a negative answer. So you really do truly need to check your answers on these. So keeping those steps in mind, let's do a few examples. Step 1 says isolate the radical. Well, in example 1, it's already isolated. There's nothing in front of it. We're not adding. It's isolated. So then step 2 says we square both sides. And you will notice that this square root sign and this squaring, they undo each other. So this is just x, and 4 squared is 16. So that's your answer. Example 2. Again, step 1 is isolate the radical. It is isolated. So here we square both sides. I'm going to put that in parentheses to remind you that we're squaring the negative 4. And we square both sides and we get x is 16. Yay, we're done. Okay, now do you see a problem here? How can this be the answer for both of these? So this is where we want to go back and check. This is to illustrate to you why checking is important. So let's check example 1. Let's take this 16 and let's plug it in where x is. What is the square root of 16? Well, the square root of 16 is 4. So this one checks out. This is okay. Let's take this one here. Let's take this 16 and put it right in there. The square root of 16. Does that equal 4? Or, I'm sorry, negative 4? And no, it doesn't. The square root of 16 is 4, and that's not equal to negative 4. So this answer, even though we did the math correctly, it doesn't pan out. This is no solution. And that's going to happen sometimes. And that's why we check our answers. Moving on to example 3. Y squared, the radical is isolated, so I go ahead and square both sides. And that's why 16 squared is 256. So I'm just going to mentally check it, and square root of 256 is 16, so this one checks out okay. Here again, example 4, isolate the radical. This radical is isolated. This 2 is underneath the radical side. You cannot simply subtract a 2 from both sides. So we need to go to the step where we square this side and square this side because the square root and the square undo each other, so I can kind of cross them out. I'm left with x plus 2 equals 16. Go ahead and subtract a 2 from both sides, and x is equal to 14. Again, checking your work, grab the 14 mentally, put it in there. 14 plus 2 is 16. Square root of 16 is 4, so this one checks out. It's correct. Looking at example 5, all right, we finally have one where this radical is not isolated. We have this minus 5 to get rid of. So step 1, to isolate the radical, we need to add a 5 to both sides. And now I have square root x equals 13. Then I'm ready to go ahead and square both sides to give me x equals 169. Then if we plug that back in here, square root of 169 is 13, and 13 take away 5 is indeed 8. So this answer checks out. All right, now we're moving on to example 6. Isolate the radical is step 1. This radical is isolated. There's nothing in front of it, behind it to get rid of. So we go right ahead and square both sides. I have 2y plus 3 equals 81. And now I need to solve this resulting equation. It's just a simple two-step equation. So we subtract a 3 from both sides. And I get 2y equals, 78. Dividing both sides by 2, half of 78 is 39. Again, check your answer coming up here. 2 times 39 is 78, plus 3, 81. Square root of 81 is 9. So this answer checks out. Looking now at example 7, the square root x is being multiplied by 7. So to isolate the radical, my first step has to be to divide both sides by 7. So now this radical is isolated. And 56 divided by 7 is 8. Now I'm ready to square both sides to get x equals 64. Again, check your work, putting it right here, put the 64 where the x is. Square root 64 is 8, and 8 times 7 is indeed 56. So this answer checks out. Moving on to example 8, I do need to isolate the radical. I have a plus 2 here that I need to get rid of. So I'm going to subtract a 2 from both sides. And I have now x plus 35 is equal to a negative 1. Now I'm ready to square both sides. I'll put that in parentheses and square it. So we end up with x plus 35 equals 1. Then we need to subtract a 35 from both sides, and I get x equals a negative 34. So let's check our answer. Bring that negative 34 right here. Negative 34 plus 35, that's 1. So I have the square root of 1 plus 2 equals 1. I'm just writing this out so I can check it. And then I get, we have a problem here. 1 plus 2 is not equal to 1. This answer did not check out. This is a garbage answer, even though we did all the math right. And if you want to look for a hint here, if you go back up and look what we had right here in this problem, after I did this step of subtracting a 2 from both sides, the result was the square root of x plus 35 equaled a negative 1. Right here is a warning flag. Can you take the square root of something and end up with a negative number? And the answer is no, we can't. So had we recognized that, that would be a real indicator that we could run into some problems. But finish the problem, check your answer, and see. But for our example 8, there is no solution. All right, let's look at example 9 now. We have a lot of cleaning up to do to isolate this radical. The first step we need to do is subtract a 23 from both sides. So that leaves me with negative 2 times the square root of x plus 1 equal to 17 minus 23, if I did that right, is negative 6. Next step, we need to divide both sides by a negative 2. I get square root x plus 1 equals 3. Now the square root, the radical is isolated. I'm ready to square both sides. Square this side, square that side. This radical and this square cancel or undo each other. So I'm left with x plus 1 equals 9. Subtract a 1 from both sides, and I get x equals 8. So let's plug that in, and let's check. This is going to take a little writing for me. I can't do this all mentally. So I put the 8 in where the x is, 8 plus 1, and we'll see if this does indeed add to 17. Square root of 8 plus 1, 9. 9 times 2 is, square root of 9 is 3. 3 times 2 is 6. There we go. And is 23 minus 6 equal to 17? And yes, it is. So this answer checks out. So my answer is 8. All right, now you have the knowledge you need to do section 8 in chapter 11. So have a radical time with that.